Hello everyone, it's a great pleasure to be here today in the session Surveying the Past, Geomatics in the Study of Megaliths and Tumuli, organised by Hugo Perez. So thank you, Hugo. And also a great thank you to all of the organisers of this Congress under very difficult conditions in the world today. So my name is Gail Higginbottom and I'm presenting the title of Landscapes of the Dead. When I started to work on this presentation, as one often does, I reread my abstract of my proposal, and it made me realise that some of the main ideas that I had basically 2 years ago have changed quite a bit since that time. Primarily, that is because of the new discoveries I've been able to make along with my colleagues about the way I think about dolmens and tombs in both Iberia and Western Wales at this point. And also because not now relating to ideas of change, but some things we can't present because we were unable to do our field work in the UK for some of the outcomes. But we have so many results, we're going to more than fill the time. So rather than just itemize ways in which I think differently now, concerned compared to the abstract, I'm really just simply going to explain the geomatic methodology, present results, and explain some of the new conclusions to date about these landscapes of the dead and what kinds of considerations are made in the choices of the locations of megalithic monuments in Western Britain and Northwest Spain. It will be quite clear, I think, that the megaliths, the sky and the landscapes and the dead are all part of some greater cosmological scheme played out and expressed by all these elements together. So let me share the screen with you. And here we go. So as I've said before, we're going to be looking at geomatic approaches and looking at using 2D and 3D modelling techniques to recover perceptions of the Neolithic and Bronze Age worlds. So this talk, excuse me, is basically going to be a reduction of 2 projects. One is called SHOW, Shared Worlds, which has been kindly supported and funded by the EU. And the second is the Western Scotland Megalithic Landscapes Project, which has been funding my forays into the field in Scotland, and also by the Digital Preservation Projects, which is funding things like congresses as well as field work. So this is basically a recreation of a map made by Bettina Schultz-Paulsen for her 2016 work on the expansion and appearance of megalithic monuments within Europe. So I just wanted to show you that I'm working primarily along the Atlantic facade, and we are going to be concentrating Northwest Scotland, Anglesey in Wales and Pembrokeshire, and here down in northwestern Iberia, and Galicia in particular. So just to reiterate, the main elements of this work will include today information about monuments, landscapes, and skyscapes. The construction of the dead and how they're treated will not be discussed a lot today because I just have too much to present to you. We could be here for the whole day if you like. So I just want to focus on those 3 elements, but the important thing is, of course, they are all related to the dead because our locations are the monuments with which the dead are associated. So they are part of this entire research project. So we're going to look at information held in monument structure, as well as landscape structure and how architecture, in a sense, relates to landscape. So we're going to look at, for example, the shape of the landscape that surrounds every single monument, particularly defined by horizon lines. So literally what's out there, mountains, perhaps rivers and seas, particular humps in the landscape, but then also how does architecture relate to the landscape? So obviously its actual location tells us about the fact that the landscape surrounding this spot is possibly relevant. But in what ways is it relevant? And that's what we want to know. And the form of the architecture can tell us something about where we perhaps should be looking, or what place in the landscape is more relevant than the other, or relevant in a different way. So, for example, you might have an axis of a stone row. We might think to look in both directions, or you might have a corridor of a tomb, and so we may be looking out perhaps of that tomb. They're just examples of the kinds of things I'm talking about. Okay, I need to instruct you on a little bit about astronomy, but not too much. So basically, we have here a lovely horizon shape that I was telling you about before. This is a person standing next to a structure like a dolmen looking out. Now, what this little picture tells you is that where the sun sets in the landscape on the horizon is dependent solely on the altitude of that horizon. So here we are, person number one, looking out here, could be you or me, and we're watching the sun go down here into this nice notch. But if we were standing in exactly the same position, but the horizon was different, when I looked still in that same direction, the sun's not setting there, it's setting in further up. Okay, so the shape of your landscape depicts where you are looking at in relation to astronomy. So you have to take into account things like that. The other thing is how the sun moves up and down the horizon, or indeed the moon, through the year for the sun. So we're now looking at a horizon. Let's look at the top line. This is a photograph of the sun rise at the December solstice, okay? So each strip is actually reminiscent of, let's pop this in here, and you can see me, and we'll make it smaller. So each strip is actually a photograph taken from exactly the same spot every month. So what we noticed is, first we have to know that, let's stop that, north is on your left and south is on your right and east is center. So sun rising quite close to the south, in the southeast. But as we travel along each month, the sun starts rising closer and closer to north until we reach the summer solstice. And then of course the sun turns, we say, and then it goes slowly, slowly back down, moving towards the south. Okay, so that is the general movement of how the sun appears in the year. It moves up and down the horizon, north and south. Now, I just want to then present how we present that information, in our 3D models that we use based on elevation data available from various government bodies, such as the Ordnance Survey from Britain, or for our other projects, the Galician government here. And they're available online for free, and you can do what you want with them. So we've chosen to make these 3D style landscape panoramas. So here is north and here is south, just similarly to this nice little photograph. And we find, if we look at the yellow lines in the northeast, this is a representation of where the sun will rise and its path through the sky, going up and then disappearing up into the sky. The next yellow line is where the sun will rise at equinox. And the next yellow line is the sun at the winter solstice. This is important because we'll be looking at these models later. Okay, now the red line is the only other line I'm going to explain on here for you. And that is equivalent to, when you're at the horizon point, the point where the moon will rise at its most northern position that it only ever comes up at every 18.6 years approximately. Okay? Right, moving on. So now that I've given you a little bit of the background, I'm going to talk about 3 projects if we've got time. So the first project is going to be about the relevance of place in prehistoric Iberia in relation to the dolmens of Galicia. So this is our study area. This is Galicia here, and this is our study area here. This section, outlined in red, is Costa de Morte, or Coast of the Dead. And the extension of our case study area, we pulled it straight out because we wanted to include the watersheds, because watersheds are very good at denominating kind of territorial areas where people are operating. The blue dots are where our megaliths are. They are exposed dolmens. So we have about 4,000 in Galicia. However, this is the number here. The blue dots are the exposed dolmens, either through, of course, weather and time, or raiding, looking for gold and such like, which is another amazing story on its own. So here's a little look at some of the dolmen types. I've just got 2. So this is one of the largest style, Acetos and Babantha, actually, but it's so lovely I had to show you. It's quite large. The individual stones can be up to 3 meters. And here's one which is, of course, much, much smaller, but they're both polygonal style tombs, and you can get them with and without corridors and different kinds of corridors. And this originally would have had a capstone as well, of course. So the idea here, you can see this is a fabulous panoramic photograph of the landscape surrounding the dolmens. The dolmen has a mound still, so that's lucky for us because it helps us understand context. And you can see the shape of the horizon here. So we are looking at the shape of the horizon as if you were standing at the position of the dolmen before it was created, because clearly you choose a location before you build the dolmen. Okay. These are our 2D profiles that and models that we've used to create a landscape around every single site in our Costa de Morte case study area. So the top graph is basically the shape of the horizon, the top of the black line, and that represents altitude. And this represents the wrapping horizon. So here is north and here is south. But we have south there, so you can just kind of look at one end so you can see south at both sides. It gives you continuity. And the second one is a logarithmic graph at the bottom of the distance of each point, every 0.04 degrees around the horizon. So at southwest, if you run down, we're at 0.8 of a kilometre away, the horizon point. So if I'm standing at the horizon, I'm looking southwest exactly, and that horizon is only 0.8 of a kilometre. But if I'm north, if I spin around, standing at the same point, sorry, looking north, not if I'm north, looking north, that horizon is 8 k's away. And we could extract the ASCII data to carry out statistical analyses of various kinds, which we'll quickly go through now. Whoa, what's that? Okay, so what we have here are the individual horizons of the 32 sites within Costa de Morte, our extended case study area. But just so you don't get too freaked out, here, remember, here is the horizon line. That's what this is an equivalent of. And this one, because just to surprise you, sorry, our readouts came with south at the center. So this is south here, and that's south there. And this one is about 8 k's away. So this particular horizon profile sits about here. What we did was we ran a number of tests. Some of them, we did some k-means tests, which I'll talk to you about in a moment. But we also decided that we wanted to know if the locations of every monument together were different from random points around our case study area. So we chose about randomly, chose about 342 random points, and we made horizon profiles for all of those as well. And then we've got a nice average here. This is the average shape of the profile for the expected data, okay, if a profile is going to be random. This is actually the average profile of the observed sites, that is our actual case study sites. And we found that statistically, the horizons in the east were highly statistically significantly different to the random sites. So something's going on about the east that's really important to these people. We've chosen to have horizons that are lower in altitude in the east. Deliberately chosen that. Okay. So we also did a k-means cluster analysis of all the 32 horizons to see if there were different horizon styles. And the cluster analysis chose 4 separate groups. We've got 8 here and 14. And what we found is that when we joined them together through another cluster analysis assessment, there was almost no difference at all between them. So it was doing a very finite differentiation here in this test. So 14 and 8, which is 22 sites, were essentially very, very similar in their basic forms in terms of horizon altitude, shape, and distance. Horizon shape, beg your pardon. Okay. So what we did then, we thought, well, let's compare these 22 sites versus the random sites. And what you can see quite clearly now is that the horizon of the observed, of the actual dolmens, has dropped significantly on both sides. And our significance of the perhaps irrelevant and chosen horizons runs nearly all the way from north-northeast to south-southwest. So this whole range, basically. The other thing that you'll notice that's really different between the random sites and the real sites is, in fact, it's far more undulating. There are more like this. Now, what I'm going to tell you is something about the yellow lines now. You're probably thinking, what are those yellow lines for? Basically, and very intriguingly, these are the rising sun points. Okay, so at the summer solstice, the sun rises in the northeast at the edge of this prominent ridge. Around the equinox, doesn't have to be exactly at the equinox, but at some point around there, right? This is the actual equinoctial sun, but it rises out of this notch. And then we've got the sun flanking the ridge on this side. And the same happens very similarly, but not as clearly in the west, which perhaps we might expect because this is far more statistically significant, the relevance of the eastern horizon. I'm going to represent this for you now in the 3D landscape models. So here is one particular site, and now you can really see those ridges. So now we've got north, south, east, west, sorry. So now I've got this one here. This is north in the center, and the bottom one has east in the center. It's basically this one blown up. Let's look at the top one. North in the center, looking to the right at the eastern horizon, you can see the yellow lines where the sun is positioned on those ridges. Now, what's really even more interesting now, once we made the 3D models, you have the moon's rising at northernmost extreme rising in the north, right at the edge of the flank. And we have the moon in its most southerly rising point in 18.6 years at the edge of the flank. Now, this also seems to be occurring on the other side, but I call this my stereotypical landscape because Pedro Cuberta is like the best one of all, but there are others that are very, very similar. And here's Pedro Cuberta. Here it is in real life, so to speak, real photograph. Okay, so we have also done, let's just flip back. We've also been doing now astronomical work on the orientations of these dolmens. Benito Villas Estevez has actually gone to every site. We've all visited every site, but his job was looking at the orientations primarily. And we've been doing some work on that, and the results are very exciting at this stage. And we've got different levels of results and different complexity. And as soon as they're out, you can have a look at any of our academia.edu profiles for the preprint links. We look forward to presenting those to you. But in the meantime, we just wanted to point out quickly some cultural, material cultural items that may connect also with solar or other astronomical phenomena. There's something called, many people who do Iberian archaeology will know this already, the solar oculares. Here we have a nice little plaque that was found in Campolomero in association with the dolmen. This is in the Museum of Pontevedra. It's very sweet. And here are some other forms of artwork, megalithic art in other parts of Iberia. So we have a fabulous ocularis here. We've got a nice crescent moon here and a crescent moon here. But of course, crescent moons are also often linked, particularly in the Mediterranean areas, with cow horns. But mythologically, it's also lunar. Here's the work of César González Garcia, along with Benito, who I mentioned earlier, and Felipe Criado Boireau, where they were looking at very particular dolmen and how the sun at the winter solstice would go down the passage and light up the lower area of the painted megaliths and at the bottom stream, and only there. But you'll find that in Iberia, sorry, not Iberia, beg your pardon, in Galicia, particularly in the northwest, there are very few tombs facing the winter solstice, which is very intriguing. Let's move on. So here's our preprint, our first one, on the landscapes of the coast of the Death. If you would like to grab that, or of course, on my academia.edu page has a preprint link if you decide you prefer to access it there. First forays into Wales, using the same methodologies that we have used in Iberia. We just very recently began, and not yet finished, modelling to recover perceptions of the Neolithic world in southwest Britain. So here we are in the little square on the, sorry, rectangle on the bottom left. This is Pembrokeshire up close. Anglesey is here. We're only looking at Anglesey and Pembrokeshire together briefly, and then we just focus on Pembrokeshire. Up close map of the little diamonds, and these are all the chambered tombs in the area. And I, though, focused on the chambered tombs that both Vicky Cummings and Alistair Whittle had looked at, and I used their list of tombs because we want to compare our results with the great work that they have done already. Just so you can have a quick look at what they are like, particularly if you come from areas where you haven't had an opportunity to engage with dolmens from another region. Very varied, and some similar. Some that may look a little bit more happy in Brittany or Iberia, such as this one looks very like Rebos in Galicia. Okay, so once more, we created these 2D horizon profiles. So you've already got a sense of what is going on there. So I'm just showing you that this is what we did. And the first thing that we decided to do was for these sites was, again, we did a k-means clustering, and we did it for all of Anglesey and Pembrokeshire together. And what we noticed was that, just to remind you, k-means clustering, basically this test chooses the horizons with the most similar shapes and puts them together. So notice the bottom group here. It's quite a lot in that group. Basically 26 out of about 42, 26, 36, yep. So there is a significant group there which are banded together in Western Wales. And we find that with the shape of the horizon, remember south is in the centre now, and this is east, that we have a shape which is higher in the east than in the west. But we do have a small group here, if we include this as well, and it's Wonky Hill. We have a group that's the reverse of that. Clear clustering of reverse, but very dominating very much, at least together, Anglesey and Pembrokeshire, of a higher horizons in the east and lower in the west. Let's look just at Pembrokeshire. When we look at Pembrokeshire on its own, it's actually, you find two split groups. And so we have, interestingly, when you have Pembrokeshire in its own, we have 8 that cluster together with a little bit of a hump in the east and a major hump in the west. And then, because I like to include these ranges together, we find that this horizon is rising in the south and travelling out to the east. So you have more of a feature in the southeast, south, and a little bit in the southwest. These are 2 dominant ranges, types. Why, we don't know yet. We're moving in. So here's the 2D profile example. So now north is in the west. Okay, we have that western group, which is higher on one side than the other, and in the east. This is the group that's running, because it's reverse, I'm afraid, southeast through south and down to southwest. That's that second dominant group up the top that you saw. And this is the group that another group, which is the reverse. So you've got some higher in the east than the west, still a smaller number. But how far away are they? We did k-means analysis for distance. We did the same for the other group as well in Galicia, I should say the other group. And you can see for all of them together, there is a dominance of 18 sites which share a very similar distance pattern. Let me just quickly check something. Yep, this is for Pembrokeshire, I beg your pardon, 28 sites. 18 of the 28 sites share a very similar distance pattern. So this is the lime green, and it's the shape of the whole thing. So overall, we have a more distant horizon overall in the east than in the west. But in the west, southwest, there's a little bit of a hump there. Overall, the distance is shaped in this fashion. So what we've found, if we're just looking at Pembrokeshire at this stage, is that we have 8 sites out of 28 which have a dominant horizon in the west, but the distance of the 4 patterns, just to go back, yellow and green, but of the 4 patterns here, only 2 of them are relevant, and one of those is, of course, the one where we have the eastern horizon overall further away than the western horizon, but in the west it drops down quite a way, and half of them present that and half present another distant pattern. Yet for all the sites that have the dominant horizon, those 2 groups in the southeastern area to southwest, almost totally this particular group love to have that horizon profile a little bit higher in the east and then dropping away in the west. So we have a sense of what's going on, but let's, at least with horizon shape, how does this relate perhaps to the rising and setting of the moon and sun for their most significant times in their cycles? Well, does this look a bit reminiscent to you? We have the equinoctial sun roughly in the center of the ridge. This is the ones that have ridges in the east and the west, and the moon at the most extreme flankings of a distinct ridge. Okay, very similar. This is the one at Higginbottom. Just to give you that I would say though that in Western, in Wales, they're much more like this side rather than the east. It's much more like the western side. Okay. So this is as far as we've really got with Wales, and we want to do orientation assessments. We do know places like Preprints, but this is actually in Anglesey. We know that the sun is associated here at particular times of the year for this particular tomb, and this is the example here. So you can see it's at the summer solstice, but we want to do an entire assessment of the whole area. Some people have done sub-regions, but where we're working now, we wanted to do that work ourselves. That's just to show that George Nash has done some work. I just wanted to honour him here in this talk. So we want to look at orientations linked to landscape qualities, difference between areas and 2 types, and so on, and why. Standing stones. This is the last area. This is actually standing stones in Scotland. I've done a lot of work on this, and if you want to read more about it, please go and see. I have quite a lot of links to papers on my page that are mentioned before, and there's quite a few either totally open access or available through that academia.edu webpage. Otherwise, go to the links from that page. So here we are. As you can see, the left-hand side top little rectangle around northwest Scotland. And these little yellow dots are basically all the sites that I originally started my work on some years ago, plus new sites I've visited since. But these sites come from, and I need to, again, talking about honouring people, is Clive Ruggles did all the orientation work at these sites that are on with the yellow dots on that map, with a team of people, and they spent a number of years gathering this information. It's a fabulous job. Okay, what do they look like? So this one here is a photograph of one of the earliest stone circles in Scotland and possibly all of Britain. It's called Stenness. And here is Callanish. So Stenness, sorry, is in the far north on a little island called Orkney. Callanish or Callanness is on an island in the west of Scotland, the northwest, an island called Lewis. Fabulously laid out. And what we're going to talk about today, though, are the Middle Bronze Age sites, which appear from research that I have done so far with my colleague Roger Clay. It appears that they have an interest in the same kind of astronomical phenomena that the first stone circles had an interest in. And they do it in a different way, but we don't have time to discuss that in detail. But what kind of landscapes do they love? How do they love to mark out the astronomy, and what does it mean? Well, let's just get back to what the stones look like first. Very big or very tinsy, but they can also be stone rows. This is a slab, so you look at orientations along a long slab. If you have something like this, you're not looking for an orientation on this kind of stone. You would be looking to see if there's an orientation between this stone and another standing stone that's visible nearby. There's a man mentioning Stonehenge only because now I want to talk about death. Standing stones are associated with the dead. Simple standing stones, in particular in the Middle Bronze Age, are known that when you remove the stone out of the stone pit, there is cremated bone in there, and often it's not an entire cremation, right? It's not an entire cremation. The very first standing stones are associated with dead in different ways. Those stone circles, there was cremated bone found in the hearth in the centre of Stenness, and Callanish is associated with a barrow just outside of its circle space of a Neolithic burial. And much later in the Bronze Age, people erected a small chamber tomb inside the circle. And the little red dots here in Stonehenge, you'll notice that in the later Neolithic, we have cremation burials associated with the pits, the Aubrey holes that run around within Stonehenge, as well as some just gathered around those stones. And of course, Mike Parker Pearson is also, along with Mike Pitts, are saying, well, maybe there's a possibility there were stones there now, and they have been discussing their theory on that. So the dead, the cremated dead, primarily are associated with standing stones, okay? Transformation, transformed dead. So you've seen these 3D landscapes now, you know all about them, you're an expert. So let's look at what were the orientations in the Middle Bronze Age. So this is a landscape around a standing stone group on the Isle of Mull. And when you're standing there, you have this fabulous landscape. Can you see it's high in the north and low in the south? Well, basically, roughly half of the landscapes and the sites that we've looked at have that kind of rough shape. They don't have to be two peaks. It could be one hill, or it could be very low, but two little peaks. The point is the north is closer and higher. The south is further and lower in altitude, often water in the low direction. And then we have roughly the other half, the opposite. The north is very low, and the southern areas have higher horizons. So we have statistical evidence in Western Scotland for alignments towards the moon at its most extreme risings and settings, both in the north and in the south. We also have not statistical support, but we have interests in the sun risings and settings at the solstice summer, but we do have statistical support for rising and settings of, the winter sun rising and setting in the south. It's rising, that's the setting. And we do have a lot of support for the moon in the south at its most extreme rising and setting point also. Through orientations. We also did some work on landscape shapes, and we found that they were different to average on the Isle of Mull, from random sites on the Isle of Mull, that the sites that the monuments were found at seemed to be quite different to the average random landscape horizon shape on Mull itself. So I just wanted to show you here, look, we're at two separate sites. These are two different sites that have a very similar horizon shape, and the link to the landscape is the same. The highest point in the northeast is where the sun will rise out of, and the sun will set into the slopes of the highest area or peak in the northwest. And these are the kinds of things that you see a lot of. The other thing you see a lot of course, because of the latitude, but also how you decide to arrange your sites, where to put them. You'll see the moon, which is a red line in the south, far left and right of your models here, is very, very close to the horizon. So it just rolls along, and it would look beautiful in a full moon. We'll go at the sun solstice, perhaps. So it's just some nice landscapes I wanted to show you, and of sites which have very distant horizons, but the horizon's shapes are basically as I've described. And for sites that are small and in an enclosed space, the horizon shape is still the same. So essentially here you have a high horizon behind it in the north and a distant horizon in the south. And these create basically amphitheatres. And it's the same for the sites with the more distant horizons. You just have a massive amphitheatre. But here we have nice little, small, cozy, great place for ritual atmosphere and amphitheatres. I'm going to give you, this is my last example now of a very particular site. It's called Gruline, and these are what are called the reverse sites, where you have a very, very low horizon in the north and a high horizon in the south. These are two stones which are about 250 meters apart. And the reason I'm bringing this up is I want to explain to you that even if you're only 250 meters apart, you will see the astronomy differently according to where you are in relation to those mountains. So this one here, I call it the witness of the mountain and the moon, and that's this stone. This stone is witness of the sea and the sun. So the story goes something like this. First, let's look at the orientations. This stone, if you're standing at this stone looking through that stone in an alignment, you will see the sun setting at the summer solstice. If you're at this stone looking at this stone, you will see the moon rising up this southern point here over the hill in the south. But if we're at the summer solstice, it will go like this. I am here at this stone looking through this stone, and I see the summer solstice rise whilst excuse me, sorry, set, I beg your pardon, I did say rise tonight, set. So what happens is after that sun sets, soon after, this moon will rise, and it can be a full moon, because the full moon can only happen on the opposite side of the sky. And from this stone, when you're looking through here to look at the moonrise, what you'll notice is that the moon will skim all the way over the top of that mountain, the mountain of the moon. But if you're standing at this side, the moon clips this hill and it drops behind the hill and behind this point here. So the full moon cannot be seen on full view for the whole time at this time of the summer solstice. And also together they bring 24 hours of very bright light. There's all this kind of play going on. So it's not just about orientation, it's about your position and what kind of amazing view do you have. And with the southern horizon blocking the south, what happens? Can you see the fact that even the winter sun, in winter at the solstice, you'll almost never see the sun. See this site here? This stone looking through here will never see the sun again apart from in the morning for a brief hour, half an hour. It will see the glow though. You see a fabulous glow coming along, but the sun itself is only seen a little bit, and the moon never at its extreme rising and setting. So it's just changed totally according to where you put your monument, where you decide to put it, will totally change the astronomical show that you will see. So this place has an amazing summer solstice play out in the sky, but also a really intriguing one at the winter solstice. It will be really dark there. Great for bonfires. So it's not just about orientation, as I've said, but neither is it just about the sun and the moon. So now we've been able to put our models into something called Stellarium. Those other models previously that I spoke about, sorry, I should have mentioned Andrew Smith, who creates his fantastic modeling software called Horizon, which is available online for yourself. So have a look at that. This is Stellarium, and we have put our models, we can now output models. Andrew's doing all these add-ons to this fantastic software, and we can put them into Stellarium, plug in the right date, as we do with Horizon, and location, put in our models, and watch how the sky would work over 24 hours. We can play it in real time, we can speed it up. So what we're looking at now on the screen is the same site that we just looked at here, the southern area. These are the southern hills, okay? So what happens at night time, at the winter solstice, is that a number of bodies roll up along here and over that mountain. It's the same hill from which you can barely see the sun here, or maybe not at all at this end, and also the rising of the full moon at the summer solstice. Remember, going over the top. So let's have a look here. Sorry. Just at the end of these other examples I'm going to show you, we'll see all those little planets going over. Stellarium has also showed us that, in fact, that at the summer solstice and the winter solstice, sorry, in the north, that as the sun sets and as it disappears, this peak is lit up and the rest of the horizon is dark. And then when the sun rises, this peak lights up just before sunrise. So these peaks are important, and they're laid out that way with the lovely glow at the different times of the year and day. This is midnight at the summer solstice. What happens, it's really amazing, and I know my talk is way too long, but I'm going to tell you anyway, because I think you'll love it. So what happens, you might have seen in the north at the other sites, usually we have 2 humps, but this side only has 1, but I just like the photo, I want to show it to you. At midnight on the summer solstice at 1500 BC, you'll find that the sun will glow dead north. This is actually the definition of true north, midnight, sorry, is that the sun is going to be dead north. However, if your horizon is too high, you won't see the sun appear. So usually what happens is you might have 2 hills like the others, the sun vanishes, and then at midnight it appears and then it vanishes again. So you get this beautiful sun glow at the solstice. The other thing that happens is this Ursa Major. But it is a fantastic asterism, which means it's the really bright stars that are very, very obvious as a group as they travel across the sky together, and they're circumpolar. So every site can see this. At midnight, the second star at the summer solstice will be dead over north. And then, it's just another site, I'll just go through. See if I can flick through, sorry. And then what you'll find is that at the winter solstice at the same site, it's just a bit too high up. Whoops, sorry, we're going through to the acknowledgements straight away. I think I'll just trip back here. We'll just go back to here. So this is the summer solstice, and we have that second star coming shown over north. Well, at the winter solstice, Ursa Minor appears in exactly the same, basically same position. It swaps. And its second star, because it's a little hook too, but it's tiny, its second star is dead north at midnight at the winter solstice. Very intriguing and fabulous thing. Of course, that's just how astronomy works, but these are the kinds of things people would be looking at and seeing. This is just to show you how Stellarium works and how beautiful it is, and also to show you the Ursa Minor. Oops, sorry, I'm flicking through here. Here's the Ursa Minor asterism, second star, dead north, midnight, winter solstice. Okay, we'll just finish with this last little picture here, which I keep flicking through. So I just wanted to really let you know how the sky itself with the landscape can be emphasized through location, why the monuments are put in a very specific position, and also you can track time through the night by looking at the stars, of course. And it's a fantastic thing to be able to do here even. So here we are at Ardna Cross, and this is about 5:30, and here we go with the, you can see again Ursa Major is spinning around, and then at 9 o'clock at night it stands dead above the standing stone, which you are in line with. It's actually Stone Row. So if you're standing along that stone row at 9 o'clock at night, it stands up in a lovely straight crook, like a shepherd's crook above the stone. And these are the kinds of things we have to think about when we try to understand why people choose a certain place for a certain monument. What kind of landscape do they want? And how they introduce all these astronomical phenomena together with the dead. So I'll finish with just 2 lines about a small amount of interpretation from my previous work, which is basically, I think that these stones are standing witnesses of this cosmological design that they can see, you know, how, and the cycles of life, and the dead themselves go through particular cycles as they're transformed in cremation. And as I've written in an earlier paper, that in a sense are they like the waning moon? Is the moon a representation in a sense of these people? And the cremation helps to speed this along so that when they're put into the stone pit and the stone is put on there, and we've got this fantastic ritual and bonfire, and all the stars and planets are aligned with the orientations, do we then create the witness? And the witness stays forever for the people. So I'd like to finish there and say thank you, and of course acknowledgements to all of my colleagues who've worked with me on these projects. Thank you very much.